Okay, so you've had 3 accents. You've had an Australian, you've had an Austrian, and now you've got an English. So, you know, we're not all Hugh Grants. I'll try not to rabbit on. I've got a presentation of 100 slides and 4 videos, and I've got 20 minutes to deliver a 10-year journey. Gavin White alluded to CLT been in the UK for 12 years now. We've been a big, big part of that journey. Yep. I'm just going to switch it on. So I'll try and spin through it as quick as I can. So as Helmut alluded, we've got an exclusive partnership with Binderholz for the UK. We, B&K Structures, of which I'm Managing Director, we are the UK's largest solid wood contractor. We not only do the designs, i.e. we do the structural engineering. We recognise that in order to move the UK market along at a great pace using solid wood, we realised that, well, there's no natural resource or manufacturing for CLT or glulam in the UK. So the UK is, what, 20% of the size of the United States, and effectively, we had to shoehorn in a product that people would accept and pay the price and the premium for. The only way I could do it was to integrate it with other materials, notably structural steel. Steel and timber are symbiotic of each other. They seamlessly fit. If it fits in a BIM model, it fits on site. Now, Arnie's pretty passionate about wood is cool. Well, I tell you what, wood took a 44-year-old steel construction business to be what is the UK's largest solid wood engineering business. I have got some other day jobs as well as being MD. President of TRADA, the 83-year-old timber research and development company, which I'm very honoured to be there as chairman. And I've become more of a preacher going around the world explaining why we should be using solid wood. So yeah, B&K Structures, we pretty much take all those materials and we pretty well force it together. Now we've been able to do that through BIM. BIM has made that happen effectively. We could take the IFC models of Tekla and CADWorks, put it together, and we can regurgitate it back out in the Revit model. So as a business, we not only do all the pre-construction, we go out and we educate. And so the feelings I'm getting from this conference is there's a lot of work to be done here, taking it to developers, architects, and engineers to give them the guidance and confidence to work. So I've got structural engineers who are daily in offices upskilling that kind of knowledge. And of course, we do the construction. So where I took my passion for wood actually was from Canada, can you believe, about the definition of what hybrid structures are. Yeah, absolutely. It is exactly what it says. It's the connection and joint details that are crucial for hybrid structures. That's what makes it stand up. That's what makes it work effectively. So what have been the drivers in the UK? Well, 10 years ago, it was the big carbon challenge. It was about carbon footprinting. It was about using low carbon materials and the carbon sequestration to get it carbon neutral. That's kind of moved on at a great pace now. Nobody's truly interested in about sustainable materials. It's about cost. But what people are more interested in is the operational carbon in the building's lifespan, i.e. how can we reduce our energy bills? Well, that's simple. Mass timber offers that straight away. The connection details alone, if we get it right, will give you the robustness, reducing the air tightness, thus reducing the energy consumption. But above all else, and Darryl alluded to it, timber weighs 20% of the dead weight of concrete. So that has a big impact on the foundations. Now, CLT high-rise in London, everybody wants it. Why? Because it means the difference between shallow pile and deep pile construction, especially when you've got all the London Underground, you've got the services. And above all else, it's about 6% of the dead weight of steel. Above all else to us, it's a quick, dry build solution. And of course, our clients like it, those who expose it, because it feels and looks warmer. I'll come on to some case studies, because that's what I'm really trying to get to. So, where have we managed to penetrate mass timber? We managed to get into all those, into education, residential, sports, leisure, and the retailers. The retailers pretty well stuck the journey together. So, I'll try and get through these as quick as I can. So this is University of Essex. This is a business school. It's whitewood spruce. It's a spruce and larch, and it's a mixture. Ostensibly, it's a glulam frame with cross-laminated timber floor decks, offering the bracing, if you like, to the structure with some internal tree houses. There you can see the BIM model. That's how it looks in its completed state. And I've tried to be as I would say, converted as possible. So there's approximately 62,000 cubic feet of wood in that project, or 1,750 cubic meters for us on the other side of the pond. And you can see there sort of how the client wanted to expose it. But again, you see the connection details, the seamless connection details. So each of those connections weigh approximately half a ton, and it's using glued embedded rods in the end of the glue lamp with using captive nuts, and therefore it's a pretty seamless connection. University of Nottingham, this is the GlaxoSmithKline funded. This is going to be the first carbon neutral sustainable chemistry laboratory in the world. And you can see there the BIM model is all coloured up because it's the construction phasing. And there you are. That's how we were going to build it. The structural frame, glue lamp, cross-laminated timber, the floor walls, the chimney stacks. And, of course, there's some construction shots. They were taken about 3 weeks ago on the site, and they're just about to clad it now. And it really does. It's like a cathedral inside. It's just a real celebration of wood, something we're really, really proud of. Now, education's taken other formats. We listen to the clients. We listen to their means. And these are sort of the new school concept in the UK. We're going away from the old modular boxes of schools and classrooms to create open space learning environments whereby the building has residual use as an asset after its lifespan has been a school. The reason for using glue-lam beams, of course, well, of course, it can become a leisure centre, become a warehouse, become retail space. But as a business, we managed to maximise the efficiency by creating bowstring trusses and doing all the precast concrete. So education, we say primary schools, I think kindergartens for you guys. There you can see the different types of structures, obviously using larch and external environment because it's more durable in service. And then you've got true CLT structures. There's the BIM model, and of course very much exposed, especially in the circulation spaces and the like. So yeah, we did quite a few primary schools. We did about 40 in total. The bigger thing has been the high schools, and we do call them high schools now because my kids go to high school in the UK. I went to a secondary school, but they go to high school now. And there you can see how CLT has given a very quick flat pack solution. To create the spans, we can use glue-lam, we can use structural steelwork. It's all about giving them sort of cost-value relationships. The biggest one to date is Fairness Academy, quite a significant amount. This was built in a total of 19 weeks. So we did the glue-lam and the steelwork in Tekla. We then took CADVEX and we modelled all the CLT, and using BIM IFC files, we managed to merge the two together for the clash detection. We gave that back to the services engineer under a common data environment. He did the services coordination, and the job was a great success. And you always do something special on every project, and this project had 19 metre, crikey, 19 metres, I'm trying to think, what's that? Put a zero, times 3 in it, 60 feet. Yeah, 300 feet, yeah. No, what, 300 feet about? No, 19 metres. 60 foot. Yeah, so you're doing 60-foot panels, triple spanning on a structural steel frame. Plenty of academies, so combined school projects, about 92. This is very common now in the UK for a quick dry build construction. Structural steel frames, CLT decks. Now, CLT decks are starting to replace metal deck concrete and precast concrete, because of the weight and because it reduces a wet trade out of the construction process. And then you see the black panels on the outside. They're actually glue-lam structural frame panels. And I'll talk about them more interestingly, where we can use mass wood in different environments. These are projects in construction on site taken last week. A nice auditorium with a glue-lam with CLT deck, all visually exposed. But then you can see in the bottom right-hand corner, again, the use of how steel and timber work harmoniously together. It works in millimetre tolerances. And there you can see how it works effectively. You see the bottom right-hand corner, all that tape, that's air seal stop. And we've got a simple logic. If rain can't get in, air cannot get out. So the residential market, this is where it's really sort of picking up momentum in the UK right now. So we did Banyan Wharf, interesting building, 9 stories of cross-laminated timber and 2 stories of in-situ concrete. Now the building rotates. We looked at all forms of construction and design, structural timber panels, pure CLT. Well, the answer was a CLT frame. And it worked quite well. And again, you know, don't be adverse because, you know, it's simple in the UK. The steel guys don't want to do timber. The timber guys don't want to steel. Well, you know, somebody's got to take a leap of faith. And this actually drives product to market, and one is successful to the other. And I'll explain why that relationship comes on. So here's the construction video. It's always nice to see nice, pretty pictures, but until you truly appreciate what goes on out there. So the contractor, the developer, sorry, was 30 weeks in the ground doing the basement, the 2 stories. Because he didn't understand what product he was going to go with, he put a concrete core. That concrete core could have been in CLT. Then great, we come on board and we took approximately 28 weeks with what I call one hook or one crane with 6 guys to construct the 9 stories. And you can see there how the building rotates. We dropped in all the plasterboard. You know, it wanted 90 minutes fire protection. So we got the CLT thickness, and we got two layers of plasterboard on there. And we worked with the fire engineer, and we did some fire testing physically on site in one of the compartments. So that's how it looks. There's some of the construction shots. As soon as the windows was in, that was fantastic. It meant the contractor could do his facade and his fit-out concurrently, which reduced his construction program by 30%. And there's the finished shots, and nobody knows it's a CLT building. I know everybody wants to expose and see it, but the developers see life differently. The way we see it is 0 to 4 stories, we'll never compete with stick-built timber frame. 4 stories to 13 stories is a CLT solution. Above 13 stories, it's got to be a steel or concrete frame, but possibly mixed in with cross-laminated timber. So this is typical as well in London. This is a mixed-use development. You've got 3 stories of office space, 3 stories of residential. Again, why do we use structural steelwork? Because we created the open span living requirement, the open span working environment. We use cellular beams so they can run the services. And somebody picked up yesterday about a timber lift shaft. Yeah, absolutely. People love it in the UK. And there's always a driver in the UK. And at the moment, the biggest driver in health and safety is dust, silica dust. And I talked to the guy who's installing the lift shaft, and he said it was brilliant. Because if he was coring into a concrete wall, he'd be exposing all the dust. He said it's a timber wall, mass timber, I just put my screws straight in. So we've done some good, if nothing else. Service risers have become very, very popular, prefabricated service risers off-site with all the mechanical, electrical. Okay, so my colleague Gavin White from Rambles, we worked with Rambles and we designed Dalston Lane. If I can just draw your attention to the big wall, the blank wall you see there, that's quite interesting because you're about to see the evolution of cross-laminated timber. This is a pure CLT job. There's no more than 4 tons in the project of steel, and that steel is just forming the connection plates back to the floor. So there's some construction shots late 2015. This is taken on site last week, and yeah, we do get blue skies in England, even though the English weather is very similar to the Portland weather, which I was a little disappointed about, guys, because I thought America was always blue skies. And there we are, some shots coming up, and it's a straightforward design. Now, obviously, all the internal walls are in cross-laminated timber because they're structural walls, because they're structural bearing. We could have put steel in there, or we could have put a glue-lam beam in there to create the spans, the open span living. And those apartments are already sold. Now, that blank wall I mentioned, this is the interesting part. This is prefabrication. That blank wall was 500 millimeters away, sorry for the term, to the existing wall. You can see the closeness of the brickwork. So we developed with Binder a totally prefabricated solution, do the assembly off-site of actually taking it to the finished surface with the vapor membrane, the insulation, the gasket, the air sealing joint. And we dropped it in, and then nobody has to go down the elevation, and it's finished. So this is taking CLT to the next level, which is coming on. So we've now developed with Binder our mega wall solution, which we're about to do on the University of Warwick Innovation Centre. So commercial office space for mass timber. Quite a few people in the audience I know I've taken, they've visited over the pond, and I've taken to Sky Television, Sky TV, which is part of the Fox network. This is their Believe in Better headquarters. Now here's some of the construction shots. Now during construction you'll see the connections are exposed. The building is under fire load. We basically went back and we plugged them, screwed them after. So again, I want to show you a video. You see the black panels again? Well, they're actually structural glue-lam cassettes. Reason being is, well, because basically we can lift mass timber up because it's much lighter as a composite panel. So this is around January 2014. The idea to build it in timber was only derived 3 months earlier on a blank sheet of paper. Sky wanted to be environmentally friendly. They wanted to build a well-being facility for their staff so they could enjoy a timber building. So we come on site in March 2014. It took us approximately 12 to 14 weeks to get the frame up. It doesn't matter on the weather because it's a dry build construction. And you can see there we're using all the exposed connections, the columns, the beams. The CLT is forming the floor decks, it's forming the spine wall to give it shear stability. And that's one of the beauties of mass timber. You're getting your bracing action. All the lift shafts, circulation spaces. And we had a 5-ton truss up there just to restrain the plant loading. Now you can see whipping around the building quite rapidly are those big glue-lam panels. So it allowed the contractor to effectively put his rain screen on, put his curtain walling on, put his roofing in, and then do his mechanical, electrical fit out concurrently. So the whole process of the construction you see now started January 2014, and the client moved in September 2014. So it was a 9-month build process, which it didn't have to be a glue line frame, could have been a steel frame. But nevertheless, it ticked the right boxes, it gave him what it was, and I believe the building, and I'm using US conversion, it was 80 foot tall with approximately 60,000 cubic meter of timber in the glue lam, the cross-laminated timber, and the timber wall panels. And I think we're about there with it. Yep, near enough. But Sky went on the journey. They just didn't do this one. They started doing their office block, and the office block was quite an actual success itself. So there's the finished shots of Sky. You can see there's no connections visible because we used the timber to protect the fire, to protect the steel in a fire. Now, coming from a steel background, if a steel portal shed or building is unprotected in a fire, it will yield, it will bend after 15 minutes. Timber's predictable. It'll at least 60 minutes fire resistance on a 240 mil square column. On GSK with the columns of 500 square. But of course, what's the driver? The carbon footprinting. So we developed with Edinburgh University a carbon footprint, and we put all the quantities of steel, cross-lam, glue-lam, timber cassettes, and we worked out, and we got a very, very clever measuring system. We proved that the building was carbon negative, using carbon sequestration. And that's based on actual materials being used and transported to site from Austria and within the UK. So Sky then went on and built the Europe's largest open plan office block, which is not far short of an airport terminal. And this had 5 miles of glue lam beams in here supporting the roof. But the roof itself was a little bit more clever than that. I'll turn that off. This is my guys on site putting in glue lam cassettes. Now these cassettes, or these roof panels, are completely prefabricated. So it looks like a metal deck from the underside. It's a perforated trocar deck for acoustic purposes, but it's got the bitumen felt already installed on a glue lam frame. So the guys just drop it in, and we were laying approximately 500 square meters a day on 14,500 square meters. And I'm sorry for not converting that, but it didn't take as long as to put in. So there they got that roof pretty watertight and dry without having to put any netting underneath. And the services guys were following us within 7 days. So it was a real success. That's how the building looks now. I went there myself, the client's handing it over. And yeah, it looks pretty impressive. And I think it's testament to the use of masswood. And again, it was a completely connection-free building. We developed with the architect how to hide all the connections, and it worked well. So then Sky said, well, we've got to give all our 10,000 employees on site in West London somewhere to exercise. So they built a gymnasium in wood, perimeter walls of cross-laminated timber and floors. And we developed with Arup, the world's first super beam. So we took a downstand glue-lam beam and we rotated it horizontally. So my engineers worked with Arup's engineers, and we created this near-flat soffit. And you can see there the soffit, you can see the glue-lam beam, and you can see the CLT panel of a very, very domestic grade because it's all visually exposed. And then they said, come on, we'll put a feature staircase in. So rather than a CLT board with Toblerones in, let's do a nice glue-lam beam and make a nice feature out of it for them. So that's how that building looks. Other commercial office spaces, we actually dabbled with mixing CLT planks with precast concrete planks because the client wanted the use of thermal mass. Now, concrete has tolerances of its own, you know, and this is what we learned. If you're going to use concrete and use it and solid wood together, keep the concrete simple. Keep it to your transfer slab, or keep it to your lift shaft. Try not to mix it in. And I say that because we bore the scars of that, and no, I didn't make any money out of it either. So that's life, that's as it is, but it does look fantastic, and the guys living there are really enjoying it. Woodland Trust headquarters, I know quite a few people in the room have visited there. It's a complete CLT structure. As I say, we do things new. In the top right hand, we suspended 4-ton concrete radiator panels, again for thermal mass. So what we had to do a lot of plate testing in our factory. So we took 18-meter long spanning CLT planks, we bonded the precast underside, and we put a lot of heavy load on there. And the beauty is, and I'm not an engineer, but I understand engineering, the Y modulus of wood, it bounced back beautifully. And we take a lot of people around. The bottom right-hand picture, I absolutely adore that one, is the fact that you've got glue-lam, you've got steelwork, and you've got CLT all mixing together beautifully. So other commercial buildings down at the Olympics, so you see the nice London red buses. Other sort of commercial projects where we do geodesic Structures and the like. And I've got to throw this one in because I'm actually quite proud to be associated with this. There's a bit of Star Wars. Star Wars Episode 8 is going to be filmed here at Pinewood Studios. Now, what's the use of solid wood got to do with this? Quite simply, they wanted a quick build solution. So we designed them a highly engineered acoustic composite panel made of glulam and cross-laminated timber. So effectively, we took one of these buildings, and then within 4 weeks, it looks like this. It's completely finished. So all the walls and roof panels were constructed in 4 weeks. Because timber is so light, it allowed us to put big panels up weighing less than 3 tons each. So it all started a journey in Austria. There you can see the glulam, braced with CLT and OSB board, highly insulated. And there's the last panels leaving the factory. And you see there we even preformed the gutters in there because wood is that versatile, it allows you to do anything. And here's the construction shots of the roof and the walls to achieve that within 4 weeks. And it's been a great, great success. So when you see Star Wars Episode 8, you know exactly where it's being filmed. West London, not far from Heathrow, on the corner of the junction of the M40 and the M25, if anybody wants to go there. So the sports and leisure section. So glulam, we know it's got great span capability. So we did centre parts. These are the UK's longest spanning glulam beams. Now, the white, it's actually made of larch, which is your Douglas fir equivalent, which is absolutely criminal. They span 250 feet. We wrapped it with a glulam frame for the roofing and the ETFE. And we might be, again, because of the preciseness of the connection details, we've got this constructed in under 5 weeks. And there it is now in operation as a holiday park. So sports and leisure, again, what can we do with wood? Well, we can create wonderful, beautiful looking buildings. We do geodesic structures. There's the BIM model. Again, without BIM, we couldn't have created it. Again, we use the seamless connections from the glulam back to the structural steelwork, again, engineered within millimetres, and that's how that project looks. And of course, retail, where it all kicked off for us 10 years ago, when I've got a retailer saying, I want to build a building in wood, what are you going to do about it? We took a leap of faith, and the bottom right-hand corner shows these big open spaces we created in glulam. But this is the cost versus carbon arguments. So the client wants glulam, and now 10 years ago, glulam was probably about 20% more expensive than steelwork in the UK. He didn't want to pay that. Okay, so we do a steel frame construction, we do a glulam frame construction. So what he's spending more on a glulam, but he's getting his carbon neutrality. But if he goes for his steelwork, he doesn't get his carbon neutrality and he's paying 20% less. So we developed the hybrid model. So the back of house in steel, the front of house in glulam, but then we start using the tensile compressive strengths of steelwork to create bracings and the like. And that becomes absolutely phenomenal. So we can actually maximize the efficiency of solid wood by integrating it with other materials. So this is Marks & Spencer's, a very typical British brand. This is their flagship store up near Liverpool in the Wirral. And again, this is a great combination of a steel deck, glulam joist at 600 centres, LVL down 10,000 square metres, that's about 100,000 square foot of laminated veneered lumber, steel trees, and then the beauty of wood curved. And of course, what made it stand up, the connections. The steel primary connections made it work, and it looks visually stunning. And again, it looks like an airport terminal. It looks fantastic. So the different materials we use in the UK, we're lucky, we're sat on Europe. We might not be in Europe by June 24th, by the way. We use whitewood spruce, which has been great for the supermarkets. Again, you can see the constructions, and if you look where the big Y column is, just at the back of it, we actually created inverted truss. So rather than having a deep glulam beam of 1 metre deep to get the lightness around, we created these inverted trusses. You see the connections are all exposed because it's not under fire load. It doesn't need to be encapsulated. And of course, we use larch, which is Douglas fir. I prefer working with larch. It hides a multitude of sins. So I even got carpenters on site constantly sanding down all the marks and the like, and it's a great material. And then, of course, Sainsbury's, the last one. This we built in just over 9 weeks. Car park, glulam frame. If you notice, there's no secondary. I think you call them girts. We call them purlins in the roof. That's all hidden in the structural roof panels. So it looks like a metal deck construction. It's not. It's a glulam engineered panel. So again, this is where we can use mass wood in other material products. Again, so the retailers want this great journey of exposing, celebrating wood with CLT underside. And of course, BIM. So we got an order. 9 weeks later, we created the model. We then put it back into Revit for the client who did the clash detection. We're on site, and then we build it in 5 weeks, frame and roof. That's what we can do with solid wood. and BIM integrations. So, right, minimum standards. These are so important, guys. So, Director of the UK Structural Timber Association, we developed with the UK Health and Safety Executive and the Chief Fire Officers Association calculations of using mass timber during construction and in post-occupancy by doing measuring all the radiant emitted heat. So we've now got the 16 steps to fire safety in the UK, which is totally approved. Chain of custody, we in Europe, we enjoy PFC. You guys, you've got to have FSC. If you've got material that is sourced from legal and sustainable forest, you can make the claim for carbon sequestration in your carbon calculator. Build off-site. So this is where masswood is going in the UK now. People don't just want the material, people want latent defects insurance. They want house insurance. I think one of the presentations earlier said the bank wouldn't support the use of the materials because it didn't recognize it as a product. Well, it's now recognized. So we've got BOPAS. That's backed by Lloyds Bank and Santander. So if there's a private equity investor buying a private residential development, they now have a 60-year guarantee for the material itself. And again, this is just driven out the 10-year experience of dealing with solid wood and the UK insurance market. TRADA, I'll explain what we've been doing in TRADA. So if you get the chance, go onto that website, structuraltimber.co.uk, and that gives you the design guide to separating distances for the construction of cross-laminated timber. It's well worth the look. So TRADA, what we've been doing as their president, we recognise that you can't put glue-lam and cross-laminated timber buildings up to steel specifications. Why steel specifications? Because they give the tolerance guidance for the design manufacture of steel buildings. So what we did as TRADA, we took all the industry heads, we took our competitors, we took my good friend Andrew Lawrence from Arup, and we were kind of the mum and dad for it, and it took 4 years to develop. So I've become a bit of a preacher at the moment, and this is free to download, so I recommend you download it. So we got out into the UK public, the National Structural Timber Spec. So it makes timber or mass wood stand side by side with steel and concrete, and it's giving guidance to architects, engineers, and developers that they now have a standard specification for the use of glue-lam, cross-lam, LVL, stick-built timber panels. Really worth it on SIPs. We threw SIPs in there as well. So we've just issued as TRADA hybrid construction, which is all solid wood construction products of glue-lam and cross-lam integrated with other materials. Again, I recommend you go on the website and see if you can download it. Some great project examples. So I'm rapidly trying to finish off. So this is the process of what we B&K Structures do. There's my guy. We're from Derby, not far from Nottingham. He's doing the BIM model. He then sends it over to Austria. Helmut and his crazy gang, they kindly do all the manufacturing. Helmut's allowed me to show this. This is their factory doing the 125 panel. There's the lamellas, all edge glued using whitewood spruce, and then it's compressed together. And then the beauty is, of course, not only creating the plank, it's going to go into the CNC process. The post-process is absolutely the key to it because it is in within millimetres. And cross-laminated timber, unlike timber frame, is a stable product. We construct with it and we have no issues in its tolerances on site. And especially when you build in the winter or the wet weather, it's a stable product. You know, it doesn't grow, it can absorb moisture, but you just put an end grain sealer on, but those are the tricks that we've learned. And these are my projects in the UK. You can see my guys there putting up the panels, should be going a bit quicker. And you can see where we've integrated with steel so we can create span. But of course the CNC is so important to it because it fits together. A project like that we'll put up in, 6 weeks? Quick dry build. The way we kind of describe CLT and low-rise in the education market is structural block work. So basically you can do the facade, it's usually brickwork in the UK, and it can be fitted out concurrently at the same time. Again, this is where we come from. It's reducing 30% of the construction program. Okay, I think I won't say too much more about that. So that's me wrapped up, I think. So before you do any clapping, and I hope you do, the one thing I would say, guys, and listening to the conference is stick together on this, because if you stand side by side and collaborate, you really will stimulate and encourage the market in the US. And the projects you're looking at are absolutely spectacular. But it's all about collaboration, and above all else, you've got to be completely passionate and believe in what you're doing in. Yeah? Okay.